Okay, today we are looking at, don't want that, that's what I want, my pen. We're looking at what's called the scalar product of vectors, or it's also known as the dot product. So it's known as the dot product because you have this dot in the middle. It's known as the scalar product because the answer that you get is not a vector. And so the answer doesn't have a direction, just has a size, so that's the scalar. So those are interchangeable. By definition, the dot product or the scalar product, u dot v, is given by u dot v. It's the magnitude of u times the magnitude of v times cos of theta, and theta is the angle in between those two vectors. All right, so some properties. Excuse me. The first one, I already mentioned that it's a scalar answer. It's not a vector answer, doesn't have a direction. Commutative just means you can do it in any order. So u dot v is the same as v dot u. Distributive. So a dot u plus v in brackets is just our normal expanding brackets, a dot u plus a dot v. And u dot u is just the magnitude of u squared, because if u and u are in the same direction, like so, if, for example, there's u and there's u, then the angle between those two, of course, is 0, and the cos of 0, not cos of theta, the cos of 0 is equal to 1. And so it just then becomes u magnitude of u times magnitude of u times 1, which is the magnitude of u squared. Okay, so example, straightforward one to begin with. You've got two vectors. If the magnitude of u is 5, the magnitude of v is 4, and the angle between them is 120, what is a dot b? So a dot b, I don't know why I've written that, should be u dot v, shouldn't it? Not a dot b, anyway. So u dot v is magnitude of u times the magnitude of v times cos of the angle in between. So 5 times 4 times cos of 120. So we then need to get our calculator out and multiply those. Or we can actually not do it by our calculator. We can use the unit circle if we need to. And so that will be 5 times 4 times negative 1/2, which would be negative 10. All right. So that's a straight one, forward one. All right, so that's if we've known some magnitudes and the angle in between them. Now there is another way that we can find the dot product, and that is using the algebraic method. So if you've got a couple of vectors, these are u and v, they've got an I, j, and a k component, and you want to do the dot product of them. If we write those vectors out in full, like so, this is what we end up with. Now, if we head back to what we looked at before in the properties, and so the distributive, we multiply those in. So we would just do those like we would normal expansion. So I'm just going to do the first bit. So we would have x1 I dot with x2i plus we would have x1i dot with y2j. And then we would get that expansion, and we would have x1i dot product with z2k. Now, the thing is, when we go to using our definition, okay, magnitude of v, magnitude of u, magnitude of v times the cos of the angle in between them, remember the ij and k, they're unit vectors, and we'd use them for direction. So the magnitudes we're talking about here is x1 and x2. And cos of the angle in between them, cos of 0. Here, x1, y1, y2, I should say, and the angle in between them, I and j. So remember, I is in the x direction, j is in the y direction, and by definition, they're at 90 degrees to each other, so that's cos of 90. That's equal to 1, but that's equal to 0. And similar here, we've got the magnitudes, which is x1 and z2, I and k. So I is in the x direction, k is in the z direction, and by definition, those two things are at 90 degrees to each other. So equals 0. So out of all of that, all we end up with, well, all we end up with, in fact, is x1, x2. All right, and we can follow that same process, expanding for the y, the j component, I should say, into, expand the k component into. And so when you do that, what you actually end up with is that, where are we, u dot v, in the algebraic sense, is just x1, x2, plus y1, y2, plus z1, z2. All right, and the reason we end up with these things here is a similar analysis to that, but we would have j times j and the angle between them 0. And for the z part, the k component, k times k, and the angle between them 0. All right, so that is the algebraic method. So if we've got our vectors written in ijk or ij in 2 dimensions, we can just use that. So let's have a look at an example. So if u is equal to 3i plus 4j plus 2k, and v is 6i minus 4j plus k, got my little vector sign there, find u times v. Okay, so as we've, u times v, u dot v. So as we've just looked at, what we need to do is you look at your I components, and you go 3 times 6. Then we look at our j components, plus 4 times negative 4. And then we look at our k components, 2 times 1. And so 18 minus 16 plus 2 would be 4, I believe. All right, so u dot v for these two vectors is 4 when we use the algebraic method. All right, so we can use that in different ways. It says solve the equation I plus j minus k dot. All right, so that's a dot. 3i minus yj plus 2k equals 4 for y. So what we're doing is trying to find what this y here is, this coefficient in this j component of this particular vector, so that the dot product of those two vectors is 4. So the dot product of the vectors, the I bit, 1 times 3, plus the j bit, 1 times negative y, plus the k bit, negative 1 times 2, and that's got to equal 4. Okay, so 3 minus y minus 2 has got to equal 4. And so what do we got? We've got 1 minus y has got to equal 4. And so y then, I believe, should have to be negative 3. All right. Now, so we've looked at the algebraic method of doing the dot product, and we've also looked at the definition of the dot product up here. And so, seeing as we know those things, we can actually combine them to find the angle between vectors. All right, so here, as these two things stands there, it's really not obvious as what the angle between those vectors might be. But we can use the dot product, figuring it out, and we can use that other definition of it to help us. So our original definition, here it is, u dot v is the magnitude of u, magnitude of v cos theta. So if we want to find the angle, let's divide both sides by that. There we go, that's all right. But also remember that the dot product is x2 at 1, x2 plus y1, y2, z1, z2. So we can figure that out. And so cos theta then, we can do it in that way. Now the angle would be that we get is between 0 and 180. All right, because if we've got two vectors, we've got one pointing this way, and we've got another one pointing this way, for example, we would measure this angle in here. All right, where the same side, the head, one here, like this, we measure this angle in there. All right, so if, for example, I went there and then I went here, we're not going to measure that angle there. We're going to measure this one around here, this way. All right, so it's always going to be between 0 and 180. Now, the other reminder that I'm going to remind you is about this magnitude of u. Remember, that's the square root of our x component plus our y, our ij and our k components. All right, so if we need to use that. All right, so need an example. Let's have a look at an example. So we already know we want to find the angle. So up here, and we want to find the angle. What do we need? We need the dot product and we need the magnitudes. So let's figure that out first of all before I worry about this. So my dot product, using the algebraic method, 4 times 2 is 8, plus 3 times negative 3 is negative 9, plus 1 times negative 2 is negative 2, which is 8 minus 9 minus 2, which is negative 3. Okay, so we know the magnitude, we know the dot product value, negative 3. We need to know the magnitudes of each of these things. So we need to know the magnitude of u, and that is the square root of 4 squared plus 3 squared plus 1 squared. And then when you work that out, you get square root 26. And V, the magnitude of V, is the square root of 2 squared plus negative 3 squared plus negative 2 squared. And then, of course, when you figure those out, you get root 17. So from what I've got here then, the cos of the angle is the dot product over the magnitudes multiplied together. So my cos of the angle between these is my dot product over root 26 times root 17. And so, well, we can, of course, multiply them together. Negative 3 over root 442 it works out to be, according to my notes. Now, that's not something that we know an exact value for, so we're going to have to use our calculator for this one. So cos minus 1 of negative 3 over root 442. And so when you put that in your calculator to the nearest degree, it comes out to 98 degrees. All right, so there's our dot product. So that's all there is for today. So exercise 2C questions that are on your work plan. With those, if you need anything in there that you need clarifying, make sure you get some help with it. And as always, have fun.